tendency that we're going to be working with in terms of what is the center of the distribution. And so mean, as you know, is just another word for, whoops, that should have gone there, I guess. Sorry about that. All right, so where is our content on the mean here? All right, so mean is just a measure of central tendency that's the same as the average you worked with probably when you were younger. All it is we add up the scores and divide by the total number of scores. It's the same as the arithmetic average. And this is the most common thing. You're going to be working with mean in every single statistical problem we do once we start doing inferential stats. Same as average. In fact, when you're working with Excel, Excel has a formula for finding the mean, but it's not mean. It's not like this equals mean and then putting some numbers in. Instead, they use the word average. I don't know why they do. It seems kind of silly, but that's the way they do it in Excel. And we use the mean so often to describe important information about groups of numbers. So I'm going to take a little bit of time with this because I think conceptually it might help you. So we can think of the mean as a balancing point. Where would this bar under here need to be in order for this board to be level? And so if you can picture having a board with these blocks piled just as they are, how can you get it to balance? And wherever you get it to balance, that's what the mean is. And so we calculated, this is the data we've been working with all along. We calculated the mode, the most commonly occurring number was 8. We calculated the median equals 7.5. And look at the mean or the average of these numbers. What a messy group of numbers, because the mean is only 6. Now, if you are going to, I just have a question. Someone's asking you, well, how many dreams do people tend to have? Oh, you've been studying dreams. How many dreams do people tend to have? Which do you think is most representative of how many dreams people have? Is it the mean? Is it the mode? Is it the median? Which answer would you want to give them?
I would give them the mode.
You'd say the mode, the most commonly occurring number. That would be maybe a good choice. Would anyone make any different choice? You could just kind of describe it, right? And say, well, some people seem to have very few dreams, like even just one, but most people tend to have like 7 or 8 dreams a night, maybe something like that. But the 6, that seems like a weird number, doesn't it? Like it doesn't really fit anything very well. It's right here, and so the mean is a funny number. We have to be a little careful with it. And you know that you can actually, we'll just wait. We won't do any calculations just yet. Let's look at a few more of these images. So again, the mean is this balancing point. Make this a little bigger. This is straight from your book. And look where it lands. Here's another data set where we can see the mode is 4. We could organize it and find the median, but we haven't done so. But look at what the mean is. It's just this 6 again. These are all distributions that have 6 as a mean. Look at this one. There is not even a cube where the 6 lies. The mean is a number that doesn't exist in the data set. The mean can be a weird number. Look at this one. Here we have a mean that's 3.6. Again, it doesn't exist in the data set, but at least it seems to be around where the numbers are clustered. So this is something to note. This right here, this block that's way outside the others in the data set, this is called an outlier. It's a number that falls outside the rest of the data. In this data set, I might say that all three of these are outliers. Because the data cluster here. And you can see that these outliers have a lot of power. It's like as if these outliers are really strong magnets and they're pulling the mean toward it with some sort of a force. And so the mean is pulled toward the outlier. There's only one outlier here, so the force isn't very great. But here with three outliers, look how far it's pulling the mean. The mean doesn't even fall where most of the data is, right around here. Look at these might be considered outliers. And they're pulling that mean toward it. And so we're going to come back to this in a little while, because this is an important concept. So the mean is a really valuable indicator. It's the most commonly used in statistics, but it can have some problems. And I'm going to give you this little applet that has a few more examples of this. So let's see, I linked up in I had this open and then I think I closed it again here. So here we go. So the mean is sensitive. So what we do is we look at this data set and we can see that where the numbers are. We have a few in this like area of 7. We have 2 numbers where 8 is. We have 5 numbers where 9 is, 1 where 10 is. And look at where it balances at 9.18. That doesn't seem too bad. But this outlier is what pulled it away. We think this mean should maybe be more like 9, where the median is and the mode is. And look at what happens here to the mean when we move the outlier. If the outlier isn't that far away, the mean comes down to 9. What if the outlier is really low, far low? Look at that's ridiculous. It says the mean is 7.73, which doesn't seem to represent the data very well. If we put this nicely in the middle, we get a mean of 8.45. That seems like a good representation of this number in the data set. Let's try one more distribution and just look at what happens. What is the mode of this data set? Anyone?
9.
The mode is 9. What is the median? You can probably guess even without writing everything out. You can probably see the median, the number in the middle. Shannon, yeah, 8.
8.
And the mean is just above 8. So the mean is pretty decent in this case. 8.09 is the average. But let's take this outlier and move it way down here and see what happens. Now the mean is 7.36. It's way below the median. Do you see how this outlier pulled this mean, sort of like a magnet? Or if we pull it way up here, it pulls the mean almost to 8.82. It's like it's not paying any more attention to these 6s here. And so this little concept is an interesting and important one. And all right. And so let's just continue on, do some calculations, and then we'll talk a little bit more about mean because it's so important. These are just some examples of comparing mean and mode, but I think we've looked at this enough. This is in your book too. So let's go on and calculate the mean. And in doing so, let's look at some language that we use in this. So first of all, let's follow step one. Here are our dreams. We already know what the mean is, but let's look at how we got it. We're going to add up all the scores. So we're going to take 7 plus 8 plus 8, 7, 3, 1, 6, 9, 3, 8. Now I'm going to do this mental math. We have 15 and 15 is 30, 34 is 40, 49, 52, 60. So I get a total of 60. And our formula is divided by 10 scores. And so we have then equals 60 divided by 10 equals 6. And so we could write down M for mean, that's how we abbreviate mean, equals 6. But I want you to look at this because this is the language that we're going to be using in this class. So first off, we have M. M is always going to mean mean of a sample. So in this case, we have 10 people. Those 10 people are a sample. So mean of a sample of a group of people. A sample of individuals. This symbol always means sum. So if you see this, then you take and you sum up whatever comes after it in parentheses, just like in Excel. Except this symbol is our shorthand for it when we're writing by hand. When we see this, X stands for scores, all the scores. So what this means is if we see something like this, sigma sign with this X after it, it means we're going to add up all the scores. So we're learning a new language. So you have to be patient, just like me learning little bits and pieces of Navajo language. You're learning a new mathematical language here that's like shorthand. And then when we know the divided sign, and then we see the N. And in our class, we're usually going to use uppercase N. And the N just refers to the number of scores. And we're going to use this all the time in our class. And so let me show you another slide that has this written out a little more neatly. Mean, we're going to usually be expressing mean as just this M. Another way you could express it, and you might see it if you go online for additional help, is this something called X bar, which looks like this. It's just an X with a bar over it. That's another way of saying mean. In our class, we're going to stay with M. And I will make note of one more thing that you don't need to worry about a lot now. When we are talking about mean using this M, it means we actually have every number and we calculated the mean. Later on, we're going to come to some other symbols, but those refer to different aspects. And so for now, we're just staying with M for mean. This N always refers to the number in the sample. Sigma always means you sum whatever's in parentheses after it. X, not X bar, let me erase that. X refers to each score in a data set. We're going to use this all the time. And so if we were going to read this formula in words, usually put a parenthesis, but either way is okay. We would say the mean equals the sum of all scores. Oh, I did it again. Scores in the data set divided by the number of scores in the set. Questions about any of that? Okay, one more comment, and then I'll give you an example to do. and we'll move on. So if the distribution is normal, and remember, by normal, we mean symmetrical, it can divide in half evenly, then mean, median, and mode are going to be approximately the same. Not exactly, but they're going to be really close in a normal distribution. But you already saw what happens in the event that we have an outlier. And if we have an outlier, sorry about that, like this, or like something way out here, say a 25, then it's going to pull the mean really strongly toward it. It's going to pull the median a little bit, but the mean is pretty impacted by it. So I have this example again. The stress ratings of 10 students in the first week of statistics class were these, and use the formula to find the mean. And so you can all do that. And when you have an answer, send it in my way.